This is the video to help you out on the second day of 2-4. You already had the handout to finish your corrections. You're going to turn this in today in folders, and tomorrow we'll take a look at any remaining questions, but please make good corrections in ink and turn the keys back in to the teacher in the room. Then you had warm-ups given to you, and on those warm-ups, I want you to go through, after you've gone through them, then I want you to watch this video. So if you haven't completed those yet, pause the video, complete them first to the best of your ability, and then come back to the video. Okay, so I assume if you're back, you did them, and you're here to check some answers. So the given truths are that all Muppets are furry and bears are furry. So if it's a Muppet, it's furry. If it's a bear, it's a furry object, and therefore the conclusion someone made using reasoning, or they think they did, was so all Muppets are bears. And so the attempt at reasoning here was an attempt at deductive. They're attempting to link logical facts together and back up their argument. So the attempt was deductive. Was it used correctly? No. Then we need some reasons why. So this isn't your reason yet, this is to illustrate it. We know if something is a Muppet, then I can say it's furry. And we have the fact that if something is a bear, then it's furry. But there's no way to start from Muppet and get to bears. We can link Muppets to furry in that direction, Muppet, then furry, but we can't link furry back to bears. That would be using our logic in the converse, and not all statements are true in the converse. So they tried to use one of their facts in the opposite direction, converse of a fact, and that's not allowed unless we have proof that the converse itself is also true. Unless we know for sure that the converse is true and that's not stated true, then it's not used correctly because we're using logic in the incorrect direction. On number 2, they gave you a lot of given information and truths. This looks to me like a lot of data. In 1999, what housing prices went up by in 2002, in 2005, and in 2008. So they have data from every 3 years of housing prices that they could put into a table. So they said 3 years later, housing prices will increase 18%. So this is inductive reasoning. They're looking at that pattern in a set of data. And here's where the tougher part of inductive reasoning used correctly. It was used correctly. Does that prove anything? No. So they went through the 3 steps. They gathered some data and examined data. And they did. We're assuming the data is worthy of being looked at. They noticed a pattern. The pattern that every 3 years housing prices had gone up by 2% in their data. And they wrote that generalization or that conjecture about the housing prices data. Is it necessarily a true statement? No, but did they use their data method correctly? Yes. So I have a few more, and I want you and the people around you to pause the video, and when you guys have had a chance to talk about these, come back. So when you're looking through, you want to see if you can identify the type of reasoning, if they use the steps correctly, and keeping in mind that inductive used correctly can still give something that isn't true. Deductive used incorrectly can give something that looks true, but we can't prove it. So inductive used correctly doesn't prove anything. Deductive used correctly does. So pause the video, discuss what type and if it's used correctly and why, and then come back to the video to check to see how you did. Pause now. You're back! Okay, so the Elmo one. Elmo arrives late to class on Monday, sent to the office. He arrives late to class on Tuesday, Wednesday, Thursday, and each day he's sent to the office. So 4 days in a row, Elmo arrives late and is sent to the office. As he arrives late on Friday, Elmo mutters to himself, Elmo bets Elmo will get sent to the office today. So Elmo's looking at inductive reasoning. Did he use it correctly? Yes. He has data that on a day he arrives late, sent to the office, arrives late, sent to the office, arrives late, sent to the office. So Elmo's making that conjecture that if Elmo's arriving late on Friday, that he will get sent to the office. Ernie, notice my theme here. Ernie must show up on time to take his exam. That's a fact. So show up on time leads to taking his exam. Ernie must study in order to pass. So study leads to him passing. Ernie showed up on time. So because Ernie showed up on time, he gets to take his exam, right? And Ernie studied, so studied means he's going to pass. So this is deductive, and was it used correctly? Yes. He's using facts in the correct order to link together a logical argument. Okay, if he hadn't been able to take his exam, it wouldn't have mattered that he studied. If he took his exam but he hadn't studied, again, so each of those things was used in the correct direction. Bert did his assignment, adding lengths of sides to find the perimeter of equilateral triangles. Noticing the results for each problem was 3 times the side length, Bert concludes that the perimeter of every triangle is 3 times the side length. So Bert's attempt here is an inductive, because he's gathering data on several triangles that he measured side lengths for. Why it's not used correctly is that he's taking the data outside of what his data actually said. His data had only data for equilateral triangles. So he can't make a conclusion about every triangle, he can only make a conclusion about equilaterals. And the final one, teenagers speed more than drivers in their 40s. That is a fact. I'm not saying we're better drivers in their 40s, I'm just saying they have data that concludes that that's true. Drivers who speed cause more accidents than those who don't speed. So the conclusion someone came to and would like to be able to make the claim of is that teenagers cause more accidents than drivers in their 40s. So again, not arguing the facts, but looking to see if the facts point to that conclusion. So teenagers speed more than drivers in their 40s. So if you're a teenager, we're going to be able to link you to speeding more than drivers in their 40s. Speeding, we can point at, causes more accidents than if you don't speed. So if you're a teenager, you speed, not you individually, but you as a group, more than the 40-year-old set. And if you speed more than the 40-year-old set, speeding causes more accidents. So can we set this logic into effect? Teenagers, more speeding, more accidents. So this is deductive, and it is used correctly. This is why teenagers do mostly pay higher insurance rates than people in their 40s. So at this point, you have an assignment to work on, and the assignment's very similar, trying to tell the difference between the two types of reasoning. Was it used correctly or incorrectly? So you want to do some of the same types of things we just modeled here, and then I'll see you to go over this tomorrow.